Sanjay Kumar. He completed his BE Civil Engineering from Madurai Kamaraj University. He also pursued his ME Soil Mechanics and Foundation Engineering from Anna University, Chennai. He worked as a designer engineer for 1 year under a structural consultant in Madurai. He is currently working as a faculty member in the Department of Civil Engineering, Tyagarajar College of Engineering, Madurai. He has organized 2 national conferences at TCE in 2010 and 2014. He's also got 3 publications in international journals. He is an A-lead member for the Geotechnical Consultancy at Tyagarajar College of Engineering.
Welcome to UGC lecture series on architecture. We are going to see the subject mechanics of structure, in which we are going to see unit 2. Unit 2 comprises of analysis of plane trusses. Now this is lecture number 4. Contents which we are going to discuss in this lecture are as follows: introduction to frames, statically determinate and indeterminate frames bar trusses, analysis made in the analysis of frames bar trusses, and finally we are going to see analysis of trusses by the method of joints. A frame may be defined as a structure which is made up of several members riveted or welded to one another. Basically, a truss is a frame in which the members may be of angle or channel sections. A simple form of truss is a triangle as shown in the figure. Now, a truss is a frame which comprises of several members that are welded or riveted to each other. Now, this is a very simplest form of truss in which there are 3 members. This is member number 1, this is member number 2, and the bottommost member, bottom chord member is member number 3. Now, the point where the 2 members are meeting is known as joints. Here for this triangular truss there are 3 joints. At the ends you have support. So, these 2 arrow marks indicates the supports for the truss. So, this is a very basic and simple form of truss in which there are 3 members and 3 joints. The connection between the members may be in the form of welded joint or riveted joint. A statically determinate frame is a one in which the unknown member forces are determined by using the static equilibrium equations. Basically, there are 3 static equilibrium equations which are as follows: algebraic sum of all vertical forces equal to 0, algebraic sum of all horizontal forces equal to 0, that is sigma h equal to 0, and the third equation would be algebraic sum of moments of all forces about a point in the system will be equal to 0, that is sigma m equal to 0. So, sigma v equal to 0 is algebraic sum of all vertical forces equal to 0, sigma h equal to 0 and sigma m equal to 0 are the 3 static equilibrium equations. So, in case of statically determinate frames, the unknown member forces can be determined by using the 3 conditions of equilibrium. Now, in case of a truss, let us consider a simple form of truss which is a triangular truss. These are the 2 supports. Now, P is the external load acting on the truss. Generally, it is assumed that the load will be acting on the joints, not within at any intermediate point on the member. So, the load P will be assumed to be acting only at the joints. So, because of this external load P, each and every member of the truss, the 3 member of the truss will be subjected to some amount of stresses or load. So, the unknown member forces in these 3 members shall be determined by using the 3 conditions of equilibrium, namely sigma v equal to 0, sigma h equal to 0 and sigma m equal to 0. So, if we are able to determine the unknown member forces by using these 3 conditions of equilibrium, then such frames or such trusses are called as statically determinate frames or statically determinate structures. Now, these statically determinate frames are composed of members which are just sufficient enough to keep the members in equilibrium without undergoing any distortion or excessive deformation. Also, the statically determinate frames will satisfy the following condition: number of members in the frame M will be equal to 2 j minus 3, where in this equation m is the number of members in the frame or truss, j is the number of joints. Now, let us consider this particular simple form of truss, which is the triangular truss. Now, there are 3 members 1, 2 and 3. So, number of members is equal to 3, which should be equal to 2 into number of joints. Number of joints are, so this is joint number 1 and this is the second joint, which is joint number 2, and this is the final and third joint number 3. So, we have 3 joints. So, 2 times 3 minus 3. So, which comes as 3 2 are 6 minus 3 is 3. So, number of members m satisfies this condition 2j minus 3, and hence this structure or this frame is known as statically determinate frame. Now, let us see about statically indeterminate frames. Now, statically indeterminate frames or frames in which the unknown member forces cannot be determined by using the conditions of static equilibrium alone. For determining the unknown member forces, in addition to the 3 conditions of equilibrium, equations in terms of deflections known as compatibility equations are also needed for determining the unknown member forces. Now, for our study, we are going to see the analysis of only statically determinate frames and trusses. Now, let us see the assumptions made in the analysis of frames or trusses. All the joints of the truss are pin jointed. The other name for pin joint is hinged joint. Now, these pin joints or hinged joints will allow rotation, and hence there will not be any moment induced at the joints of the frame or truss. Frame is loaded only at its joints. This we have seen already. So, no load will be acting anywhere in the intermediate part of the member. So, the load will be acting only at the joints. The frame is a statically determinate one. Weight of the members are assumed to be negligible when compared to the external load, and hence they are neglected. Forces induced in the members are truly axial. So, because of the external load, there will be some induced forces in the members. That member forces are truly axial in nature. So, our aim is to determine the unknown member forces in the trusses because of the external load. All the members are in a single plane, which means that the truss is a 2-dimensional plane truss. Now, let us see the types of support for the trusses. The first support is fixed support. A fixed support will be represented like this. In case of fixed support, there will be totally 3 unknown reaction components. There will be a vertical unknown reaction component V, there will be one horizontal unknown reaction component H, and also there will be a moment induced. This moment is M. So, basically there are 3 unknown reaction components in case of a fixed support. The next is simply supported ends for the truss. Simply supported end is represented by a triangle resting on its base like this. In case of simply supported end, totally there will be 2 unknown reaction components, which are vertical reaction component V and one horizontal reaction component H. Simply supported ends allows rotation, and hence there will not be any moment. So, in case of simply supported end, moment will be 0 because it allows rotation. The next type of support is hinged support. Hinged support is represented like this: a triangle resting on its base. At the apex of the triangle, we will be putting a dot. This dot represents the hinged end or hinged support. Once again, this hinged support allows rotation, and hence moment will be 0. So, the 2 unknown reaction components are vertical reaction component V and the horizontal reaction component H. The final support is roller support. Roller support will be indicated by a triangle resting on rollers. Now, for such kind of supports, roller support, there will be only one reaction component, which will be vertical reaction component V. Now, this roller support allows rotation, and hence moment will be 0. Also, this roller support allows horizontal displacement. So, this support can displace towards right or it can displace towards left depending upon the direction from which the external load is applied. And hence, since it is allowing horizontal displacement, there will not be any horizontal reaction and hence H will be 0. So, the only unknown reaction component is V. So, the total unknown reaction components for roller support is 1. Now, we shall see the analysis of truss by method of joints. Now, the following points should be considered while doing the analysis of truss by method of joints. Now, we will be considering each joint in a truss as a separate free body in equilibrium, and for that considered joint we will be applying two conditions, two equations of equilibrium, namely sigma V equal to 0 and sigma H equal to 0. Sigma V equal to 0 means sum of all vertical forces at the joint will be 0, and sigma H equal to 0 means sum of all horizontal forces at the joint will be equal to 0. So, by using these two equations of equilibrium, the unknown forces at the joint under consideration will be determined. Now, the joint that are considered as a free body should be such that they should not have more than two unknown forces. This is an important point that is to be noted while doing the analysis by method of joints. Now, let us solve a problem so that we can understand the method of joints in a more elaborate way. Now, this is a simple truss, a basic triangular truss. Span of the truss is 5 meter. It comprises of 3 members and 3 joints. The joints are named as A, B and C. At the apex of the truss, that is at joint C, we have a vertical downward force of 2 ton. Because of this force, each and every member of this truss, the members are AB, BC and AC, will be subjected to some amount of forces. Those forces may be compressive force or tensile force. Now, let us consider this as a member. As we discussed before, members of the truss will be made up of angle sections or channel sections. Consider this to be a member. Now, if this member is subjected to axial compressive force of magnitude P, then within the member there will be a equal and opposite reaction offered for stability of the member. So, equal and opposite reaction will be in a direction opposite to the applied compressive force. So, the broken arrow indicates the reaction forces. Now, for the analysis of truss, we will be indicating the member by a single line like this. At the ends of the member we have joints. The joints will be denoted by 2 dots. So, a member has 2 joints at its ends. Now, in case if this member is subjected to compressive force, then the resisting force, the arrow mark should be such that it should be pointing like that of the resisting force. So, compressive force acting on the member will be indicated like this. Arrow marks should be pointing towards the joint, that is, in case if the member is subjected to compressive force, the joints will be pushed away from each other. Now, if a member is subjected to a tensile force of magnitude P, so this is a member which is subjected to tensile force of magnitude P. An equal and opposite reaction will be offered within the member. So, the reaction force will be exactly opposite to the applied tensile force. Now, this reaction force is offered for the stability of the member. So, a tensile force, a member subjected to tensile force will be indicated like this. So, the member is indicated by a line. At the ends you have 2 joints. The arrow mark will be pointing away from the joints like this. So, this is how we denote tensile force, that is, the 2 joints will be pulled by the tensile force towards one another. Now, let us come to the problem. Now, the truss has simply supported ends. Now, first of all we have to determine the unknown support reactions, Now, at the end A we have an unknown reaction component V A, and at the end B we have a vertical unknown reaction component V B. Now, at the two ends there will not be any horizontal reaction component, because if you see the nature of external load, the 2 ton external load is a pure vertical load, and hence at the two supports, at the two simply supported ends, there will be only vertical reaction components. Now, we are going to determine the two vertical reaction components, for which we are going to use the conditions of equilibrium. Algebraic sum of all vertical forces should be equal to 0 for the equilibrium of the structure. For the truss, algebraic sum of all vertical forces should be equal to 0. We are going to take all the forces going in the upward direction as positive, and hence forces going in the downward direction will be taken as negative. Now, totally there are 3 forces in this truss. The 3 forces are VA, VB and the external force 210. VA goes in the upward direction, so we have to put a positive sign for it. So, plus VA. Similarly, VB is in the upward direction, plus VB. 2 ton force, external force is in the downward direction, so it is minus 2. So, these are the 3 forces. Algebraic sum of all these 3 forces should be equated to 0. So, VA plus VB minus 2 will be 0. VA plus VB will be equal to 2. Let us keep this as equation number 1. Now, algebraic sum of moments of all forces, algebraic sum of moments of all forces about any point, say let us consider this joint A, sum of all moments of forces about joint A should be equal to 0, because joint A is a pin joint and hence there will not be any moment. So, sigma m A will be equal to 0. Similarly, sigma m B will also be 0. So, you can also use the second equation as sigma m B equal to 0. Now, once again 3 forces are there, VA, VB and 2 ton. VA passes through A and hence there is no lever arm for this force, lever arm is perpendicular distance. So, there will not be any moment due to VA about A. Now, let us consider the force VB. Now, here is our joint A, VB acts like this, VB acts in the upward direction. So, VB induces an anticlockwise moment about A. We are going to use the following sign convention for moments. Anticlockwise moments will be negative. So, we will be using negative sign for all anticlockwise moments. So, VB induces anticlockwise moment. So, minus VB into phi. Now, the third force is 2 ton. Now, if you see the inclination of the two sloping members, they are at 45 degree inclination. So, the perpendicular distance between this 2 ton force, perpendicular distance between this 2 ton force and joint A is 2.5 meter, because this triangular truss is in the form of an isosceles triangle. So, this distance will be 2.5 meter. Now, 2 ton force creates a clockwise moment about A, clockwise moment will be positive. So, it will be plus 2 ton force into perpendicular distance is 2.5 meter. So, this is equated to 0. VB will be equal to phi divided by phi, which will be equal to 110. Now, already we have seen that substituting the value of VB in equation 1, we get VA plus VB, VB is 1 ton, which is equal to 2. Therefore, VA comes as 1 ton. So, the two unknown reaction components are of equal magnitude, 1 ton each. Now, let us consider the free body of joint A. Now, this is joint A. At joint A, you have vertical reaction component VA, magnitude of VA is 1 ton. Then you have the horizontal member is AB, and you have an inclined member which is AC. Let us indicate the force in the member AB as FAB and force in the member AC as FAC. Now, our aim is to determine the force in the member FAC as well as force in the member FAB. Now, the inclination between these two members is also given, which is 45 degree. Now, these two members AC and AB may be subjected to any nature of stress, that is, it can be subjected to either tensile force or it can be subjected to compressive force. Generally, all bottom chord members of the truss will be subjected to tensile force. As we have seen earlier, tensile force will be indicated by a arrow mark pointing away from the joint. So, FAB is assumed to be tensile in nature, and hence I am putting an arrow mark pointing away from the joint. Now, we shall assume force in the member AC to be compressive in nature. Compressive forces will be indicated by drawing an arrow mark pointing towards the joint. So, I have shown an arrow mark pointing towards the joint. So, force in member AB is assumed to be tensile and force in member AC is assumed to be compressive. Now, this is joint A. Now, we are going to apply the two conditions of equilibrium, namely sigma V equal to 0 and sigma H equal to 0 for determining the unknown forces. First of all, we shall apply the condition sigma V equal to 0. Now, at joint A, you have a vertical force VA. VA acts in the upward direction, and hence the sign convention for that force VA will be positive. So, plus VA. Now, we have to find out the vertical component of the force FAC, that is FCA. This is the force FCA, it acts towards the joint. Let us construct a triangle, right angle triangle with FCA as hypotenuse. So, this angle is 90 degree, the inclination of FCA with horizontal is 45 degree. So, this is the vertical component of FCA and this is the horizontal component. So, FCA force in the member CA acts from this particular point and it ends up at the joint A, that is it moves from this particular point to this particular point. In order to travel in this manner, vertically we have to go downwards and horizontally we have to move towards left. So, the direction of vertical component of vertical component of the force AC will be in the downward direction and the direction of horizontal component will be towards left. Now, the vertical component will be, that is minus sign, because vertical component is in the downward direction. So, it will be minus FCA into sine of 45 degree. So, plus VA minus FCA sine 45 degree, this is equated to 0. Now, we know the value of VA. So, therefore, FCA will be equal to 1 ton divided by sine of 45 degrees. So, you get FCA as 1.14 tons. Now, if you see the sign for FCA, we are getting a positive sign, which means that the assumed nature of force for the member AC, that is compressive, is correct. So, our assumption that the force in the member AC is compressive is right, because we get the sign as positive. So, FAC is subjected to a compressive force of magnitude 1.14 ton. Now, we shall apply the second condition of equilibrium, that is sigma H equal to 0 for joint A. Now, if we consider this joint A, totally there are 3 forces coming at joint A. VA is a vertical force and hence it does not have any horizontal component. Now, let us consider the force FAB. FAB goes towards right. So, the horizontal component of FAB will be plus FAB. Actually, it will be plus FAB into cos of 0, because FAB is purely horizontal in nature. So, FAB into cos 0 will be once again FAB. So, plus FAB. Now, we have to get the horizontal component of the force FAC. Now, horizontal component of the force FAC is here in this triangle, below this triangle, which is represented as H. That horizontal component, if you see the direction of horizontal component, it is towards left, So, we had to put a negative sign. Horizontal component of FAC will be FCA into cos of 45 degree. So, these are the algebraic sum of all horizontal forces, equate this to 0. Already we have found out the value of FCA, which is 1.14 ton. So, upon substitution and simplifying, we will be getting FAB as 1 ton. Once again, if you see the nature of sign convention for FAB, you get a positive sign, which means that our assumed nature of force for the member AB, that is tensile, is right, and hence FAB is subjected to a tensile force of 1 ton. So, by considering the equilibrium of joint A, we have found out two unknown member forces, namely FAB and FCA. Similarly, we can consider the equilibrium of joint C, and then we can determine the remaining unknown member force, which is FCB. Now, if you do the calculation, FCA will be exactly equal to FCB because of symmetrical loading. Now, we shall summarize the things which we have learnt now in this lecture. We have seen an overview about statically determinate and statically indeterminate frames. Also, we have seen the assumptions made in the analysis of frames and trusses. Finally, we have seen the method of analysis of a simple truss by method of joints. Questions for the students to answer. Number 1, differentiate statically determinate and statically indeterminate frames. Mention the assumptions made in the analysis of truss. Finally, there is a problem for solving. Here you have a simple truss. Once again, it is a simple triangular truss. Span of the truss is 5 meter. The inclination of the member AC with respect to the bottom member is 60 degree, and the inclination of the other sloping member BC with respect to the bottom horizontal member is 30 degree. At the apex joint C, you have a 10-10 force acting. You are asked to determine forces in all the members of this simple truss by method of joints. With this, we have come to the end of lecture 4. Thank you.